All right. Hey, everyone. Welcome back. We're diving into another crucial topic today, one that's a mainstay in our daily UPSC mains current affairs discussions and could very well pop up in your prelims, too.
Yeah, the Indian monsoon. It's a pretty big deal.
No kidding. So we're going to take a deep dive into some fascinating research from the Indian Institute of Science, IISc shorted. The Hindu recently highlighted their study, and it really digs into a fundamental question.
Yeah, what makes a monsoon cloud band bring all that heavy rain? It's key to understanding, how to actually predict these things.
Exactly. And this IIC study's findings are pretty eye-opening. Turns out, it's all about the strength of the cloud band. Only those strong equatorial cloud bands have what it takes to travel north and drench India.
Right, not all cloud bands are created equal. And the older models, they kind of assumed all bands would just propagate regardless of their strength.
Yeah, like a one-size-fits-all approach. But this research throws that out the window, showing that the weaker bands just fizzle out, they dissipate, before ever reaching us.
They lack the energy, basically.
So what gives a cloud band that strength to make that epic journey then?
Well, there's this big atmospheric pattern called the Boreal Summer Intraseasonal Oscillation, BSISO.
Say that 3 times fast.
I know, right? BSISO. Anyway, it essentially moves those cloud bands from the equator towards India.
It's like the conductor of the monsoon orchestra.
Pretty much. And it dictates when we get those active periods of rainfall and when we have the breaks, the drier periods.
Oh, I see. So it's the BSO, along with the size and inherent strength of the cloud band itself, that determines how intense and how long those rain spells will last.
Exactly. It's a delicate balance.
But this strength, it's not just some random thing, right? It's got to be connected to what's happening in the ocean. That air-sea interaction plays a huge role.
Absolutely. The way the air and the sea interact down in the equatorial Indian Ocean is crucial. A stronger coupling means more atmospheric moisture builds up and you get stronger winds. And that creates those robust cloud bands capable of just unleashing those monsoon rains.
So it's like the ocean is fueling the engine, so to speak.
Yeah, good analogy.
Now, with the climate warming up, how does this dynamic change? Like, how do things shift with all that extra heat in the mix?
Well, a warmer atmosphere can hold more moisture, right? So this study projects a pretty significant increase, actually.
Oh.
Yeah, between 42% and 63% more rainfall during those wet spells.
Yeah.
We're talking about India and the surrounding seas all getting drenched even more.
Whoa, that's a huge jump. It really underscores why this research is so important for improving our forecasts.
Absolutely. By understanding which cloud bands have the potential to unleash those heavy downpours, we can make our seasonal and subseasonal monsoon forecasts even more accurate.
Right, which is vital for everything from agriculture to managing water resources and even preparing for potential disasters.
Exactly. It has a ripple effect across so many sectors.
So let's zoom out a bit and put things in context for our listeners. The word monsoon itself comes from the Arabic mawsim, meaning season. And in India, we mainly experience the southwest monsoon, right? That's the one that brings the bulk of our rain from June to September. It's driven by moisture from the Indian Ocean and those low-pressure systems that form over Tibet.
Right. And then you have the northeast monsoon, which is the retreating monsoon. It runs from October to December, but it mainly affects southeastern India.
And a whole bunch of factors influence the monsoon's behavior, right? Like the ITCZ, the Intertropical Convergence Zone, the heating of the Tibetan Plateau, all those jet streams, the Somali jet, the Indian Ocean Dipole. And then, of course, there's El Niño and La Niña, which can really shake things up.
Yeah, El Niño, for example, is often linked to those weaker monsoon seasons, sometimes even droughts.
So many moving parts.
Definitely keeps things interesting. But the key takeaway here is that the strength of these equatorial cloud bands, it's a primary factor in determining how much rainfall we're going to get.
And studies like this one from IISc, they're pushing our understanding forward, helping us refine those forecasts even more.
Definitely pushing the boundaries of our knowledge.
Now, for all you UPSC aspirants out there, think about this for a second. With the climate changing and those intense wet spells projected to increase, how should India manage its water resources? And how can we prepare for the potential disasters that might come with those more extreme rainfall events?
It raises a lot of important questions, about the resilience of our infrastructure and our preparedness strategies. We need to be ready for those heavier downpours.
Absolutely. Food for thought. And if you found this deep dive into the science behind the monsoon rainfall helpful for your UPSC prep, hit that like button, subscribe to the channel, and leave us your comments with any questions you might have.
Yeah, we love hearing from you guys.
We're always looking to explore these topics further. Our source today was The Hindu, so be sure to check that out. Thanks for joining us, and we'll catch you in the next one.
See ya!